very interesting question here. Question is somewhat confusing. Say a manometer contains mercury in place of water. If the external pressure is 760 torr. Now, P external 760 torr, and the open side is 10 cm. The height is 10 cm higher than the side connected with the apparatus. What is the pressure in the apparatus? The density of mercury at 25 degrees Celsius. Temperature was given to us as 25 degrees. Density, which is rho, is given as 13.55 gram per centimeter cube. Now, how is the setup like? The setup is like this. You have this is how the manometer is. Are you getting it now? Then you have this side. Connected with an apparatus. This is the gas. Now, he said this side, which is the side that is open, is 10 cm from here to here, higher than the side that the apparatus is connected to. The open side is 10 cm higher than the side that the apparatus is connected to. This is the side that the apparatus is connected to. This side is 10 cm what higher, which is that is to say that from here to here, or from, let's say this is A, this is B, from A to B is the side, or is the what height with which this side is higher than this side. Now I say calculate the pressure. Now you must understand something. Now, for this body to be at equilibrium, the gases are here. These are gases. This is a gas. Or this is, sorry, this is liquid mercury. Rather, this is not gas. This is liquid mercury. Let's assume that this is liquid mercury. Let's say A is here. Liquid mercury ends here. Now this is liquid mercury. For here, or for this mercury liquid, or whatever it is, to be at equilibrium, it means that the force acting here from this side must be equal to the force acting from this side. Are we getting it now? For this liquid mercury from here to be at equilibrium, or for the something to stay the way it is, it means that the force acting from here must be equal to the force acting from this side, which is the force from the left hand side must be equal to the force from the right hand side. In the same vein, the pressure from the left hand side must be equal to the pressure from the right hand side. Now, there are two types of pressure acting here. One, the open side has external pressure. It has what? External pressure. So you can call that P external is acting here plus, now the height, there are mercury from here to here also acting downward, acting on the one here. We are considering these two places. For them to be equal, we said the forces acting from here must be equal to the one acting from here. Now we said that there is atmospheric pressure. Now atmospheric pressure acts on all things. So for the atmospheric pressure, it is acting here, and also the height of the water or of the mercury from here to here is also what? Acting downward. Are we getting it now? It's more like you carry water, or you put water inside can and you kept it somewhere. What will happen? It will be exerting a pressure on that thing. For instance, let's say you fill water somewhere and you now keep it on top of another water. What will happen? The water that you filled will be putting pressure on another water. Or let's say you have clothes. Clothes is light. Let's say the clothes, you just feed it in a bucket, then you put water in another bucket, and then you put it on top of the clothes. What will happen to the clothes? The clothes will go down, isn't it? Same thing is applicable to here, because that water that you filled in that particular bucket is exerting pressure what? Downward. Same thing is what is happening here. The height from here to here, which is the mercury from here to here, is also exerting pressure on this one. Are we getting it now? So we say the pressure from mercury. This will be all the pressure due to the height. Let's say the pressure due to the height difference from here to here. This must be equal to, from the left hand side or from the right hand side, how many pressure is coming from there? Is only one pressure, which is the pressure of the gas. Are we getting it now? So we have it as the pressure of the gas. Is that clear? Like we said, that for this mercury here to be in equilibrium with this, that means to be in the same height, the forces acting this way must be equal to the forces what acting this way. It's just like equilibrium. We say for equilibrium reaction to occur, the left hand side of the reaction must be equal to the what? Right hand side. Same thing is applicable here. The forces acting this way must be equal to the forces acting this way. From here it is open, because they said the open side, there is atmospheric pressure acting on it normally. Then from here to here, it's just like you are carrying another bucket on top of the water that you already have. This from here to here is also what? Exerting a pressure, which is the pressure due to the height of what? 10 cm, which is P of what? H, is equal to, from here, the only pressure acting this way is the what? Pressure from the gas, because all gases exert pressure. So, calculate the pressure for the gas. So, P for gas is equals to the P external plus P of H. Now, our P of H is given by the formula P of H is equal to density, acceleration due to gravity, and height, H. Density, acceleration due to gravity, and what? Height. Why? Because normally pressure is force over area, isn't it? Force over area. Now, force is what? Mass times acceleration due to gravity over area. Now, what is your mass? From what we know, density is what? Mass over volume, isn't it? Density is mass over volume. So our mass will be equals to density times volume, isn't it? Mass, this is over 1 cross multiply, mass will be equal to density times volume. So from here we can say that the density given with this times volume times G is over what? A. Now, V over A is what? V over A is what? Now, what is V? V is equal to length times breadth times height, isn't it? While area is what? Area is equal to length times breadth. Normally, true or false? Yeah. Because volume is length times breadth times height, and area is length times breadth. So length times breadth can cancel length times breadth, isn't it? So what are we left with? What? H. So we can say that this whole thing here, volume over area, can be represented with what? H. So therefore, density times H and what? G is equal to pressure. So that was how we got that particular formula I'm about to write. So that was how we got pH of the gas is the density times G times H. So we have P H. I say P of the gas, the pressure of the gas, is equals to the external pressure plus the pressure, the density times acceleration due to gravity times what? Height. Now, let's take cognizance of parameters now. We already said that the pressure of the gas is equals to the external pressure plus the pressure or the density and what? H, G and H. Now, the density was given to us as 13.55 gram per cm cube. We must convert to kg per meter cube. height is given to us as 10 cm. Converting height to meter, it becomes 0.1 meter, isn't it? Yeah. Now the density is given to us as what? 13.55 gram per cm cube. Is to convert the density to kg per meter cube. Why? Because we are going to use G as what? 10 meter per second square. We are going to use G as what? 10 meter per second square. So what we are going to do now is to convert the density to what? Kg meter what? Cube. So guys, the next thing we are going to do is to convert the density from gram per centimeter cube to kg meter to what? Kg per meter cube. Why? Because we are using G as 10 meter per second square meter. So we must convert the density to what? Kg per meter cube. So therefore, what are we going to do now is to use the standard of conversion. The standard of conversion says that 1 gram per centimeter cube is equal to 1000 kg per meter cube. 1 gram per centimeter cube is equal to 1000 kg per meter cube. Therefore, 13.55 gram per centimeter cube, 13.55 gram per centimeter cube will be equal to x. Is that clear? So when we cross multiply, x multiplied by this, it will give us x times what? Gram per centimeter cube is equal to 1000 kg per meter cube times 13.55 gram per centimeter cube. Exactly. Gram per centimeter cube can cancel gram per centimeter cube. So what are we left with? We are left with x is equal to this multiplied by this will give us 13.550 kg per meter cube. So this is how to convert density from gram per centimeter cube to kg per meter cube. Is that clear? This is how to convert from gram per centimeter cube to kg per meter cube. 1 gram per centimeter cube is equal to 1000 kg per meter cube. Therefore, 13.55 gram per centimeter cube will be equal to what? X. Cross multiplied and you cancel out your units, you are left with what? 1355 what? Kg per meter cube. Now this is your density in kg per meter cube. Now what of your external pressure, your height, everything you've already converted them. What about your external pressure? Now the external pressure is given to you as 760 torr. Now 760 torr is the what? Standard external or atmospheric pressure. Please note this. Now 760 torr is the what? The standard atmospheric pressure. Now same 760 torr is the same thing as 1 atm and it's still the same thing as 101325 Pascal. Are we getting it now? 760 torr is the same as 1 atm, is also the same as 101325 Pascal. Now, but the units that we are going to use now for all this calculation, because we have kg meter per second and the rest, we are going to use 101325. So this 760 torr, in place of this 760 torr, we are going to put 101325 Pascal. Because the option we are given in what? Pascal. Are we getting it now? So what we are going to do now is, in place of external pressure, which is 760, we say 760 torr is the standard and is equal to 1 atm and is also equal to 101325 Pascal. So in place of this external pressure of 760 torr, we can put what? 101325 Pascal. Is that clear? We said the formula is P of gas, the pressure of the gas is equal to the external pressure of 101325 Pascal plus we have the density. Density is what? 13550 times G is what? 0.1 meter times, okay, G is 10 meter per second. 10 meter per second square times the height is what? 0.1 meter. Is 0.1 meter. So what are we going to do? These two, everything here multiplied by each other will give us 101325 Pascal plus everything here will give us 13550 Pascal. If you multiply everything here, they are going to give us this. So add these two things together. If you add these two things together, it's going to give us equal to 114875. 114875. Now if you count this one backward 3 times, it will be 1, 2, 3, which is approximate of 114.87 times 10 raised to the power of what? 3 Pascal. Now note that 10 raised to the power of 3 is what? Kilo. So this becomes officially 11. If you approximate this, becomes 115. Are we getting it? Times 10 raised to the power of 3 Pascal. True or false? Yes. Because this is up to 5. So if you take it 1 back, it becomes what? 115 times 10 raised to the power 3 Pascal, which is equivalent to 115 times 10 raised to the power of 3 is what? Kilo. So you have it as kilo Pascal. So that is the answer to that question, 115 kilo Pascal. It's been a long journey, right? Been a long journey. So that is the correct answer to that question. Thank you for your time.